In this brief video, we're going to talk about alignment, a very low-level but very important detail of machine architecture that every compiler writer needs to be aware of. First, let's review a few properties of contemporary machines. Currently, most modern machines are either 32 or 64-bit, meaning they're either 32 or 64 bits in a word. And the word is actually subdivided into smaller units. We will say that there are 8 bits in a byte, and then 4 or 8 bytes in a word, depending on whether it's a 32 or 64-bit machine. And another important property is that machines can be either byte or word addressable, meaning that in the native language of the machine, in machine code, it may be possible to either name only entire words, or it may be possible to reference memory at the granularity of individual bytes. We say that data is word aligned if it begins at a word boundary. So if we think about the data in memory or the organization of the memory and it's laid out into bytes, and let's say that this is a 32-bit machine so that 4 bytes make a word, and one word begins here and the next word begins here, then if data is allocated on a word boundary, say in these 4 bytes, then that would be a word aligned piece of data. If a piece of data begins in the middle of the word, so let's say for example that it begins here, we have some data that's allocated here, this data is not word aligned because it doesn't begin on a word boundary. And the important property or the important issue is that most machines have some alignment restrictions, and these restrictions come in one of 2 forms. So on some machines, if the data is not properly aligned, meaning that you try to reference data that isn't aligned the way the machine requires, then the machine may just fail to execute that instruction. Your program may hang, or even the machine may hang, but the important thing is that the program will not execute correctly. So it's incorrect to not have the data aligned properly. Now there are other machines that will actually allow you to put the data anywhere you like, but at a significant cost. So it may be that accessing data that is aligned on word boundaries is cheaper than accessing data that's on non-word boundaries. And these performance penalties are often dramatic. So it can easily be 10 times slower to access misaligned data than to access data that has the alignment favored by that particular machine. So let's take a look at an example where data alignment issues tend to come up. One of the most common situations where we have to worry about alignment is in the allocation of strings. So let's say we have this string, the string hello, and that we want to put it in memory. So let me draw our memory as a linear sequence of bytes. Okay, so I'm going to mark out some bytes here. And let's assume this is a 32-bit machine, so let me make the word boundaries a little bit heavier boundaries. So 1, 2, 3, 4. 2, 3, 4. Okay, so there are the word boundaries. And now let's say that we're trying to have aligned data, a word aligned data, and so we'll allocate the string beginning on a word boundary. So the H character will go in the first byte, then E, then L, then L, then O. And now we may have a terminating null depending on how strings are implemented, but let's assume that we do. And this is a fine placement of a string. The string begins on a word boundary, and that will satisfy, presumably, any alignment restrictions of the machine. And now the question is, where does the next data item go? So we could begin the next data item right in the next available byte, and that would be good if we were very concerned about not wasting memory. But notice that that data item will then not be word aligned, and we may either run into correctness or performance problems if the machine has restrictions on alignment. So the simple solution here is to simply skip to the next word boundary and allocate the next data item, whatever it is, on the next word, beginning at the next word boundary. And what happens to these 2 bytes here? Well, these bytes are just junk. They're not used at all. They're never referenced by the program. It doesn't matter what their value is because the program should never refer to them. It's just unused memory. And note that if we didn't have the terminating 0, then there would be the terminating null character there, then there would be 3 unused bytes after the string. So to summarize, this is the general strategy for dealing with alignment when you have alignment restrictions. Data begins on the boundaries, typically word boundaries that are required, and if the particular data that you're allocating has a non-integral length, meaning that it doesn't end directly on the next required boundary, then you just skip over whatever bytes are in between to get the data, the next data item that's going to be allocated on the correct boundary.